Alright, so I'm going to be showing you how to complete challenge 1 of Damn Vulnerable DeFi called Unstoppable. So this is the description for the challenge. So there's a lending pool with 1,000,000 DBT tokens in balance offering flash loans for free, and our job is to attack and stop the pool from offering out more flash loans. We start with 100 DBT tokens in our balance. So now we're going to go through the contracts. So to find the contracts, you go to contracts, unstoppable, and unstoppable lender.sol, and this is in the Damn Vulnerable DeFi GitHub repo. Alright, so let's go through the contracts. So the first contract is unstoppable lender. This is basically the contract that gives out the flash loans. So let's get going. So this first variable is a basic ERC20 token called damn valuable token, and it is used for the flash loans, and it's the token that the flash loans are traded in. It's very basic ERC20 token. It's just this. It's really basic. Nothing special about it. Alright. So the next variable is pool balance. This is essentially the internal accounting of the contract to keep track of the pool's balance of DBT tokens, and it's what's involved in the hack of the contract later on. Alright, now to the constructor. This require statement is simply to make sure that the token's address isn't address 0, and then it sets the damn valuable token's address. Alright, now we're on to the functions. The first function is to deposit tokens. It takes a parameter of the amount of tokens. It's an external function and it's non-reentrant, which means reentrancy attacks won't work. And here, the first line is to require that the amount deposited is greater than 0. And the next line is to transfer the damn valuable tokens from the message.sender to this contract address. And the next line is to make sure that the pool's balance is changed because of the new tokens that were deposited. Alright, now on to the main function of this contract, which is the flash loan function. Okay, it takes in a parameter of the amount that needs to be borrowed. Well, not needs, yeah, the amount that's borrowed by the flash loan. And the first line is to make sure that the contract is borrowing at least one token. The next line is to basically get a variable of the balance of the contract before the flash loan has taken place, so then the contract can know whether the flash loan is paid back. And this line here is to make sure that the contract has enough tokens to be able to give out for the flash loan. Alright, next is an assert statement making sure that pool balance equals balance before. This is where the exploit takes place, but we'll get onto that in a bit. This line is to transfer the damn valuable tokens from the transfer them to the message.sender, and to transfer this amount of tokens. This line is simply just a line to call a function on the interaction contract to be able to receive the tokens that were given away, that were lent out, and it takes the arguments of the address of the damn valuable token and the amount that is lent out, the amount that needs to be returned. Alright, next is the balance after. This is the balance after the flash loan has taken place, and it's the balance of this contract for the damn valuable tokens. And this line is basically making sure that the flash loan has been paid back by the person who called the flash loan function. Alright, so I'm going to explain the exploit now. So the exploit is basically this line means that the pool balance has to equal the balance before, which is the same as this, but I'll just show this to make it easier for me to explain. So pool balance has to equal the current balance of damn valuable tokens. This is able to be exploited because we can send tokens directly to the contract without having them being accounted for in the pool balance variable. This means that the contract is vulnerable to a denial of service attack because we can prevent it from sending out annual flash loans, since, well, this assert will fail every time because the pool balance variable will be less than the actual balance of tokens in the pool contract. Okay, so now we're going to go on to the next contract. This is just a contract to interact with the lending pool contract. Alright, it's called Receiver Unstoppable. It's in the exact same folder as the Unstoppable Lender contract, and now I'm going to go through this one. Alright, so these first two lines are just setting up the owner of this contract and the address of the pool contract that it's going to interact with. Okay, we're going to go to this line first because, no, this function first because this is the first one that will be called. So this function execute flash loan is just to start up the flash loan and to be called by and it's called by the owner, and it just calls the flash loan function on the pool contract over. It just calls this function here. And next is the function that is called to return the tokens back to the lending pool, and this is called by the pool, and this function is called by the pool here, and all it does is return the tokens from this contract that was lent them out right back to the flash loan pool contract. And that's really all the contract's done. Now let's go on to the exploit. As I said before, the exploit is simply to make sure that these two variables are different, and to do that we send tokens directly to this smart contract without using the deposit tokens function that adds the amount of tokens to the pool balance. Therefore, we make sure that the values of pool balance and balance before will always be different, and then the flash loan function won't be able to give out flash loans, basically making this contract useless. Alright, so now let's go on to the actual implementation of the exploit. So actually, I'll explain this first, the setup for the exploit. So these are just some variables about the amount of tokens in the pool that is going to be set and the initial attacker balance. And here is just getting some addresses for different people in this exploit. And so it's the deployer, attacker, and some user. These few lines here are really simple. These are just to deploy the damn valuable tokens, which are this, and the unstoppable lender contract, which is this. These two lines are basically to approve the pool contract to be able to spend the tokens in pool amount of tokens, and those tokens are deposited into the pool. Next, this token contract transfers this amount of tokens to the attacker's address, which is our address. Next is just some expect statements, which are to make sure that the balance of this pool's address is equal to the amount of tokens that were sent to the pool. And here's another expect statement, making sure that the balance of the attacker's address is equal to the initial attacker's token balance, which is the amount of tokens that was transferred to the attacker's balance in this line here. Alright, here's just some lines of code to test and see if the flash loan contract is able to give out flash loans, and that's quite self-explanatory, so we're not going to go through these lines. And here's the actual exploit. So to hack this contract and make it impossible to give out flash loans, we need to send tokens. So to do this, we use transfer, and we transfer down valuable tokens, which are these tokens here, which is this dot token, and we transfer them to the pool's address, and the amount we're going to transfer is all our token balance. We could transfer any amount of tokens. It could be 1, it could be 10, it could be anything, but we're just going to transfer all our tokens. And this connect part is basically just to connect the attacker's address to the transaction to be able to run the transfer transaction. And hopefully this will work, and it will transfer the tokens to the pool contract, making the pool contract not be able to give out flash loans and letting us complete the challenge. Right, let's test it out. So to test out the exploit, you run npm run the name of the challenge, which is unstoppable, and now we see if it works. And boom, we completed it. Well done. Let's go.